Good afternoon, everybody. Thanks for joining this tutorial organized by the STARS project. I am Silvio Brate and I will be your host for today. Let me first of all remark that this tutorial will be registered, so please have your cameras off if you do not want your face to be recorded. Let me give you a quick introduction to the STARS project. It is a European project financed by the COSME program that aims at fostering innovation in the railway sectors. It is mostly focused on SMEs, but the main partners of the consortium are several railway clusters across Europe, and that might have been the partners that have invited you to attend to this meeting. The project coordinator is Ditecfer, that is the Italian cluster based in Pistoia. As part of the activities that are being carried out by this project, we are hosting a set of webinars and tutorials for providing some insight on the advanced technologies that might feed the railway sector in the forthcoming years. And so we consider this as an action to foster awareness for everybody and to start to possibly to start some cooperation between the consortium and you all to try to introduce these new advanced technologies in the most steady possible way, allowing proficient interaction between potential customers and domain experts and research and development actors. So the purpose of this specific webinar is to introduce you all on the topic of cybersecurity of connected objects. So we are most of us is aware about the cybersecurity topic in terms of data security. So we usually refer to cybersecurity as cybersecurity of information technology, meaning that we want our data to be protected. We want to avoid data breach. We want to avoid that some malicious attack interrupts our information technology system or steals our data. But actually, this is not the only aspect of cybersecurity. A few weeks ago, we had a webinar, a tutorial about digital twins and artificial intelligence. Once we create a digital twin of any physical system, that is for providing us with useful information is being fed by real-time data that is gathered by sensors or by manufacturing execution system or whatever. We need to rely on that data. We need to trust that type of data because that data is driving our decisions. The trust can be defined in several levels. The first and obvious level of trust is due to the fact that we need to have high quality data. And for high quality data, I mean data with the proper level of correlation, the data with, let me say, the right number of digits, the right number of samples, the right number of updates per time unit, and whatsoever. So this really refers to the quality of the data. But actually, one other important aspect is that we need to rely on the fact that the data is coming from the real device that I expect to feed the system. So we need to be sure that the device that sends data to our system has not been corrupted, has not been attacked, is the exact device with the correct software version that we expect it to be. Imagine what can happen if a malicious attack sends inputs, data in our system that is on purpose errored, but even mimicking to be an high quality data. This is a type of attack that is hard to detect, but can lead us to drive to and to draw bad decisions. So the purpose of this tutorial is exactly to help you have an insight to what are the techniques and what are the purposes of protecting objects. So let me get quickly to the agenda. My colleague Florence Masbernat from the Relenium Technology Center from France will give you an insight on a technological analysis on the adoption of future technologies in the railway sector, focusing on the aspects related to cybersecurity. And then my colleague Andrea Vesco from the Linux Foundation will lead us and will provide us through a lot of information and insight about the cybersecurity of connected objects. And then we will have some time for questions and answers. So, Florence, welcome, yes. And let me hand over to you.
Yeah. Hello, hello everybody. Okay, so I need, I think, to share my presentation. Be sure that you can see it. Can you see this?
We see the PowerPoint, the PowerPoint window, not the slideshow.
Because I make an exercise. Okay. I don't know how it works. When I use it, you cannot see the full.
Now we still see the PowerPoint window. Yeah.
The PowerPoint window.
Yeah.
I don't know how I can manage this. Sorry. You know? Because I just share my screen and it should be possible to show you this. Okay. Well,
okay, but you can go like that. Just change the windows and the slides here.
Sorry. What did you say, Silvio?
You can use this window. Just change the slides here.
The window. Sorry.
Florence, you can send your presentation to me, and then I try to change it.
Okay. I will send you that. I try to do so. Okay, 1 minute. Sorry. Just some. That it will be not so. This is done. Let's see if you can. So you will share it, Lutz, that's correct? Okay. Check, receipt.
Just give me a feedback whether you can see it.
Yes, we can see it.
Yep.
Yeah, it's okay. Thank you very much. And so I will present now you this technology innovation analysis introduction that this work has been done by Rolinium in the context of STARS to answer several objectives. So if you can move to the next.
Just a minute. Yeah.
Okay, seems to work. So, so the first objective was to try to provide to the SMEs an overall picture of the railway major innovation trends and the associated advanced technology paths that will be needed to develop those innovative solutions. And so it should contribute to enhance the awareness of all SMEs to be able to adopt advanced technologies. And also it will contribute to identify what are the major railway challenges and innovation roadmap. And so we wanted also to focus on some key aspects that should be considered, like skills, for instance, to be able to take those changes with the help of SMEs. So sorry, next please. So just to present and to introduce this methodology we have been using to manage this technology innovation analysis. So you can see it is in 4 steps. So the first steps was first to select a corpus of documents and sources that will help to describe those major innovation stakes. So it means doing the state of the art that has been provided by all R&D industry and also experts from the railway domain. And so fortunately, we have very already interesting approach that were provided first by ERAC. ERAC is the European Rail Research Advisory Council. So we have here a very rich roadmap. And secondly, what we call the SRIA. So that is the Strategic Rail Research and Innovation Agenda. And as well, Europe's Rail that implements major programs to provide solutions to those changes. So starting from this state of the art, the second step was really to identify what are those changes, more precisely regarding all the technological ecosystems. So it means to extract from those roadmaps the innovation trends and the technology challenges associated to those changes. So then the third step was perhaps to detail more the technologies that are that will provide answer to those challenges. So we have a list of technologies, and as a summary of those 2 steps, we can say that we have selected and detected 8 innovation trends that I will present, 37 technology changes that were both on hardware and software issues. And at the end, the last step was also to try to identify what are the key variables and to propose some key indicators, not 10, but we try to just retain 3, that could reflect the gap to be filled by SMEs to join this technology, advanced technology approach. So those 3 indicators are, the first one is the time to market, of course, an important indicator, and what is the level of maturity of the technology at the time regarding time to market. Well, we want to have our product on the market. So then the skills, because you can see that in advanced technologies, we may have appeared new skills, and these skills may come rare or not enough developed, and may be a difficulty to have the capability to enhance the right skills. And at the end, of course, one important aspect is the budget and what will be needed to engage in terms of budget to reach the relevant technology maturity. So that it is about all the general approach. And then from this approach, as I said, we have identified 8 innovation trends. So started from 1 to 8. So the first one is the smart asset management and maintenance of the future that are very key within the railway and that will bring really some important rupture. Assets for automated or autonomous or remotely piloted operations, so autonomous train and automation of all the functions, also another key issue. Network management, planning and control, of course, very important in being able to assess the traffic management and train capabilities. The green freight logistic chain, as freight is really an important stake where we need really to increase the part of the freight within the next year, and this work will be key. The railways digital twin simulation and virtualization, and numerical aspects are also very key. And as well, we have also the necessity to develop rail services, for instance, to revitalize the capital lines, but also to develop sustainable and green rail system with typical topics of energy inside it, and also the multimodality of and intermodality of the railway transport. So that are the 8 trends that we have detected. And if we look at the cybersecurity technology, it will be really important and impacting many of those innovation trends. As one major challenge of the railway is digitalization, and digitalization bringing IoT, bringing Silvio was mentioning the treatment of big data and so on, will clearly, through, for instance, 5G communication aspects that will be key, will be a more and more important aspect in the railways. It's true that in the past it was not appearing a lot, but now there is one railway standard that have been published, integrating clearly recommendations and obligations regarding cybersecurity. And so this will be a key aspect to be strongly developed, linked to all the also telecommunication, new protocols that will be introduced in the railway. And so this is fundamental to have safe and secure railways. So just to illustrate perhaps what we can find within our matrix that will represent all those challenges and the detail of technology. So this is on the next slide, please. So here is a matrix that we have created from the technology innovation analysis, and you can see that we have a description of each main innovation trends and the segments of railways that could be interested. What are the more or less topics to be developed that could concern the SMEs, and the advanced technologies that should be involved, hardware and software, regarding hardware and software aspects. And then we detailed a little bit more those technology in this column, and we have tried to assess the key 3 indicators that I mentioned previously, to putting a number from 1 to 5. So if you need a low effort, it would be 1, and if you need a very, very high effort, it will be 5. So this clearly are some indicators, but we can see that, for instance, we have a strong necessity of, as I said, 5G networks, IoT sensors to develop, for instance, self-diagnostic components, and this will need clearly to have, if I look at my indicator, one important one is the skills. because we will need very dedicated skills to do so. And so if I come to the next point, for instance, here we will need to develop robot application for railways in order to secure more the work of the workers along the infrastructure, for instance, allowing to repair infrastructure, and that should be used remotely. And we will need, of course, to secure very much the cybersecurity protocols to do so, because we will have to exchange data and to be sure that all protocols are very robust in each cases. So maybe another example will be on the IT2, where really it's clear that we need to develop new automatic train operation solution that will be used, of course, and will be very automated. And this will need, of course, to prevent them from the cybersecurity attacks and to drive solution that we are sure that in each case it will be robust to cybersecurity. And this is also true, of course, for the remote driving and command. You can imagine that someone is going to change this protocol. It will be a question of safety and security, so that are key in those domains. So we can see also that we have a strong problematic of localization in the railway, and of course, telecoms once again will have a key role. We need, for instance, to develop some electronic cards to support all those protocols. Perhaps next, there are some illustration also for the railway services, because so we speak about maintenance, operation, automation, but of course we will need very much to develop for freight, for instance, or other services to passengers. That we will have large data platforms to exchange data to help to localize trains, to help passenger to, of course, to find their way. And this has also to involve cybersecurity protocols, and that should be strong and should allow to manage all the data that will be shared, and that has to be secure. And yes, so maybe I speak about this also. It was about all these digital services, once again, regarding, of course, real-time platform exchanging data. Sorry. Okay, so these are some examples that you can find out in the matrix to illustrate today how the cybersecurity comes to be a really important issue to be tackled by railways. Thank you very much. Yeah.
Thanks, Florence. And I think that now we can hand over to Andrea, that will, as I said, will give us an overview of what are the problems and countermeasures for cybersecurity of connected objects. Andrea, it's up to you now.
Thank you, Silvio. I suppose you all see my slides.
Yes.
Okay, so hello everybody, and thanks for joining this tutorial. Today we are going to address a very broad topic. It is the topic of cybersecurity in connected system. Of course, we will not cover everything, but we concentrate on a specific possible technology that is called self-sovereign identity. So we address the specific problem of authentication and authorization in such a kind of system. Of course, this is not the only possible approach to security, but as you all know, there will be and there are possible and different solutions that complement each other and works together in synergy to arrive to a certain level of cybersecurity. So we cannot cover everything in this tutorial, and we concentrate on the topic of identifying object in a connected system or in an infrastructure to fulfill one of the objectives that Silvio introduced at the beginning of the tutorial. So when you want to build the trust in data, one of the point to fulfill is for sure to be or to verify from the cryptographic point of view the source of the data. Because if we are going to take critical decision based on this data, we want to be sure that we are receiving the data from a specific element or objects in our infrastructure, and we also want to be sure that these data has not been counterfeit. So let's start with setting the ground. For sure, we in the last years we moved from a situation in which we have a CPU in computer to a different solution where we have microcontrol units in objects, IoT, and these MCU are today everywhere. For sure, in manufacturing system, in mobility system, at our wrist, in video surveillance system at home, and today also in sports. So we are in a situation where objects are becoming smart, have the capability to interact within the ecosystem, and this interaction must be trustable. Again, for the main reason we said at the beginning, to trust the data that they produce and the decision we take on these data. So we are in a totally different situation in which the attacks differ from the kind of attacks that we had in information system. And they differ in some specific peculiarity. So first, one of these peculiarities is, of course, the absence of a motivation related to data theft. This means that just theft data is not the main goal, but typically this kind of attack aim to, let me say, stop the operation of the system, and in some cases also in causing physical damage, because some of these systems have, of course, interaction also in the physical world. For sure, this kind of attack are more complex, and they normally require the collection of knowledge of the system, and in some cases also to perform site survey of this infrastructure. This is for sure and in particular important in case of national critical infrastructure. So this is just to set the ground, just to be sure that we are all on the same page, and we have in mind that in the rest of this tutorial we concentrate on this kind of connected system in which there are several objects that support a digital infrastructure or make themselves the digital infrastructure, and in which data flow exists between these element of the infrastructure, and there are also critical points in which decision is taken based on the data collected. As I told you at the beginning of this tutorial, we concentrate so on one single solution. This is not the overall solution to make the infrastructure cyber secure, but we start from the topic of digital identity for object. Addressing digital identity means essentially to be sure on and have the knowledge of what authentication and authorization is. So let's start from the authentication. Authentication is for sure the act of proving a claim. In this specific case, the claim is the identity of an object. No? So you can imagine that there is an object that wants to enter in a trustable digital interaction with another to exchange such kind of information, and need to prove his identity such that the receiving party or the receiving party can trust and receive the data and take decisions. Authentication is for sure different from identification. That is the act of indicating the identity of a person or of things, an object. So the authentication is the process of verifying the identity of the object. This is not enough. In such kind of connected system, authentication is not enough, but we need also to go through authorization verification. With authorization, we means the process to determine that the authenticated person of object, in this case, can access a particular service or access a particular resource, or is allowed to share such kind of data. Of course, there is a relation between authorization and authentication. Authorization depends on the authentication because the authorization requires the attributes that determine the decision of the authorized to be verified. So only authenticated person or object can be authorized to do something on the system. To introduce and arrive to the main topic of today, that is the self-sovereign identity for connected systems, I would like to see a bit the different story of identity. For sure, the very first idea of identity that we refer to siloed identity is such kind of identity that we all use every single day when we use our accounts, I mean a username, a password, to log in on a system or on an organization. So this is really the first idea of identity, in which I can access, or an object can access a service through an account. Of course, the account exists only on, in this case, looking at the slide, in that specific organization. But this is not a persistent idea of identity, because that specific account cannot be used in other system or organization. Let me say the subsequent possible design of identity is what we call third-party federated identity, in which there is an identity provider and a specific object or person have an account on this identity provider, and then with this same account you can also log in and be authenticated first and then authorized to a specific service or to access to a specific resource also in other system or organization. The third, that is really the topic of today, is what is called self-sovereign identity, in which For sure, there is a direct relation between you and your peer or an object and another one in the system. So there is no the concept or client and server, and this peer first of all enter in in secure communication through secure channel, and then exchange credential between them to be first of all authenticated and then authorized. This specific idea of identity leverage a new means of immutable storage that is a distributed ledger. And we go through the entire stack now to understand this kind of solution. For sure, self-sovereign identity, this is an identity that in which, in this kind of model, every single person or object can make its own identity and can prove its own identity to others, is in contrast when we focus on connected system to a totally different model that is the classical centralized model in which a subject that is identified through a key pair, a private keys and a public keys, need the certification of the public key from a certification authority. Because as the name self-sovereign suggests, there is no such kind of authority, and this role in some way, not completely, but in some way replaced by a distributed ledger. Any kind of distributed ledger can be implemented to arrive and to implement such a kind of identity model. So let's start from the bottom layer of the full stack of SSI, and we see here in particular that when we have different objects, in this case, two different objects, these objects interact with any kind of ledger through what is called a DID method. A DID method, we will enter in details in the next part of the tutorial, is essentially a software implementation specific for that specific ledger to interact, write and read from the ledger and store essentially identity data that will be used in authentication and authorization procedure with another peer. As you know, a DLT is considered an immutable means of storage, and so this can be used for storing part of the element that compose the identity of an object, essentially leveraging this very important feature, so that something that is written on the ledger cannot be modified. As I told you, many different ledger can be adopted, and every single node use a specific DID method to interact with this specific ledger. This is the layer one of the overall SSI solution. A layer two, every single node that want to interact in a trustable way with another have to create a secure channel with the peer. And we will see how the specific identity data stored on the ledger will be used essentially to create this secure channel. At that point, the identity of an object seems to be just a couple of keys in which the public part is stored on a ledger through the use of a specific software implementation, that is the DID method, but no more than that. This is not totally correct. In fact, at layer 2, the secure channel and the first cryptographic authentication can be successfully finalized. But this is not enough in the overall SSI model. In fact, there is another layer that is represented by this, is called triangle of trust, in which the model suggests the use of verifiable credential, nothing different than the physical credential that you have in your pocket and you use every day, but in their digital form, to finalize the authentication and go through the authorization to a specific service or to access a specific resource. If you look at the two objects here at layer 2, these two different objects are represented in this triangle of trust by an holder and a verifier. In this triangle of trust, there is another important role. It is the role of the issuer. Issuer are that specific peer in our infrastructure that prove a claim about the identity of the objects and issue a verifiable credential to one of the objects. Of course, this verifiable credential together with the data identity data used at layer 2 are used to create a proof to a verifier, nothing that another objects in our infrastructure to finalize the authentication, and based on the claim, in particular the identity in the verifiable credential, access or not to a specific service or resource. This triangle of trust also requires what is called the implicit trust between the verifier and the issue. In fact, as we will see when we will address the data model of this verifiable credential, issuers also digitally sign this kind of credential, and to give any possible other nodes to verify this credential, of course, the public key of the issuers is needed, and so there is an implicit trust between this object and agent in this system. So now at this point we have 3 different layers and at least 4 different informations that are combined to generate the digital identity in this self-sovereign framework. While, just for clarity, authentication starts at layer 2 and is finalized at layer 3, authorization is based only on the claim within the verifiable credentials and exists or works only at layer 3 of the overall stack. On top of this, any kind of connected system can be built, and every kind of objects can use such kind of identity and build the typical digital trust ecosystem. So an ecosystem, an infrastructure where any kind of objects can interact in a trustable way with another and go through authentication and authorization. This is, in my opinion, at this point, what I've said at the beginning become clear. Of course, digital identity is important, but it's just one single piece of an entire cybersecurity solution, because only deals with the authentication and authorization. Of course, there are other plenty of solutions that we can combine with such a kind of identity to reach a certain level of security. Now, let me enter in some details of this model, and let's analyze in detail the four components that form the digital identity of an object in this ecosystem. First of all, and this is the very first element of any digital identity, there is a key pair, a public key and a private key. So every single node in a self-sovereign paradigm need to generate its own key pair. Then a layer, let me move here again, a layer 2, there is the concept of decentralized identifier. Decentralized identifier are URI, as you can see here, that represents a new way to identify a subject. What is this kind of URI? The form is this one, in which there is DID, the name of the DID method, so the name of the DI method that I'm going to use to interact with a specific ledger, and then a method-specific ID. You can see this method-specific ID as an address, an index on that specific ledger. So this URI point to a specific ledger with a specific address where, and we will see how, we are going, the object is going to store is public key. So you can think the DID as a pointer to a specific distributed ledger technology, and the last part of this URI is an index that you are going to use to retrieve a public key. Where and how we store this public key, and this store is made by the use of DID document. In the next slide, we see also how this DID document looks like. But you can think about, of a DID document as again a digital document that store at that specific index on the distributed ledger the public key of the node. Of course, also one or more verifiable credentials. This is the last and fourth component of a digital identity in a self-sovereign model. Just a clarification about the possibility to use different DID method and different distributed ledger technology as an immutable means of storage. If you look at the role of this DID method, that are essentially just the the software implementation, the API, if you want, that let every single node to interact with that specific ledger, essentially the implementation of these DID methods, and any node can also have more than one DID method implemented, make the overall model independent on the specific DLT that you want to use to build such a kind of identity. Not only different nodes of our infrastructure that want to enter in trustable interaction can also use different ledger. The point is that both of them need the implementation of the specific DID methods, because to retrieve the public key of the counterpart of the peer that want to authenticate with me, I need to access the specific DLT. So 4 different components make the digital identity of an object: a key pair, a DID, of course, a DID document that is a document containing the public key of the node stored on the ledger at this specific address, and one or more verifiable credential. Why one or more? Because in the system there can be more than one issuer, and the verifier, so each node in infrastructure, need to have an implicit trust of this issuer, because they have to verify the 4 components of his of the identity to authorize, to finalize authentication and authorize a specific node to access a service, or to provide a service, to request a service, or to access a specific resource. Now, let's talk a bit about the DID document. What is a DID document? Essentially, it's a digital document in JSON format, very simple, in which, of course, there is a context, and the context point to the W3C standard, the standardized W3C recommendation, standardize this such kind of identity. There is an ID, and here, sorry, you see exactly what I mean for DID. DID is a URI that starts with the name DID, the name of a method that I'm going to use. I have to interact with a specific DLT, and an index in any form, or better to say, in the specific form of that specific DLT. Of course, there is the date, the creation date and time for the creation of DID document, and then there can be one or more public key. In this case, for example, I want to store on a ledger my public key that I want to use for authentication purpose, the first one here. Again, at my DID, key 1 can be used by a peer in my infrastructure to authenticate me using this public key. Of course, the data model also specify the kind of key and the verification method. In this case, we are going to use elliptic curve public key calculated over the Edwards curve. So I can define also the kind of public key that the peer is going to retrieve and use to authenticate me. In a DID document can be, for sure, more than one public key that I want to store. Now, if we look, let me go back and see the overall stack. And I want to be sure that you agree with me that such a kind of system is a decentralized system for identity. Why? First of all, the composition of the digital identity, in my opinion, reflects very well the decentralized nature of self-sovereign identity, because there is no authority in such a kind of framework that provide me the entire identity. If you remember that your identity is the composition of 4 different components, and you refer to a specific object in the infrastructure, he create his own public and private key pair. He define his DID. He store the public key on the ledger through a DID document. He receive one or more verifiable credential by issuers. So there is no a single authority as in a centralized system that provide me such an identity, and there is no one single authority that is able to revoke completely the identity of a peer. Moreover, a single object on the infrastructure can have one or multiple verifiable credentials. So to see the decentralized nature, we need to think about decision. A system is decentralized when there is no authority that takes autonomously a decision, but the decision of the system is the composition of the decision of the different element of the system. For this reason, and in particular for the structure of the digital identity, this can be considered really a decentralized solution for identity. Now, I want to go through the different layers of the SSI framework and take some time to discuss the different elements of these of the overall stack. Of course, starting from the bottom, the main component that we need to build such a kind of identity and to build such a kind of trustable interaction in an infrastructure is a distributed ledger. And to discuss a bit about distributed ledger, I always like to see where this kind of technology has been developed, and when someone in the research community started thinking about such a kind of technology. And if we look at the history and at the scientific publication, you clearly found in July 1982, in my opinion, the paper that is the core, or at least was the main building blocks for arriving at defining the distributed ledger technology that we know today. Essentially, a paper in which Lamport, as the main author of the paper, defined the Byzantine general problems. This problem, that is a very simple problem. There are different generals that need to make a concession on the date and the hour they have to attack a city, and they have to take and to arrive to this consensus to win the bottle. Essentially, this problem define the problem of consensus in a digital system, because every single general can also decide to maybe not misbehaving, and so don't reach the consensus. The first solution to this very interesting problem was made by Satoshi Nakamoto, that you all know was the father of the first Bitcoin network, one of the possible digital distributed ledger technology that we can use at the core of this self-sovereign identity solution. As you all know, the main difference between a centralized ledger in which there is an authority that maintain, update, and write and maintain the ledger at the in a decentralized solution, the ledger, so the data, are stored in all single nodes, and there is a consensus protocol running between or among all the nodes of the distributed ledger to maintain the same version of the ledger at the different nodes. If you look at the data structure used to implement such a kind of ledger, there are essentially two main classes in which that are typically referred to be blockchain, in which the data structure are blocks connected in a chain, or tangles, in which the data structure that maintain this ledger is essentially a tangle. So there is no chain and no blocks. And the main, at least today, solution that fall within these two main categories are for sure the IOTA tangle, or Bitcoin, Ethereum, or any other blockchain that you all know. But just to be sure and on the same page, all of them are distributed ledger technology, but so you can refer with the name DLT to both, but then blockchain or DAG or Tangle, so the kind of data structure that you use to implement the ledger define the kind of DLT. This is why when normally we talk about self-sovereign identity, we don't refer to blockchain, but to the DLT in general, because you can select the one that you prefer to implement the first layer of the overall SSI framework. Okay, this is just a slide to say that in every single DLT, there is what is called a trilemma. Essentially, you cannot have decentralization and security and scalability at the same time, but you normally can reach two of them. For example, Bitcoin reach very good decentralization and very good security, but have some scalability problem when you define scalability as throughput in terms of transaction. But this is just the classical trilemma of any DLT. So, for example, one of the you can select the one that you prefer based on this trilemma. Then on top of the DLT that you selected, you can develop or use one of the DID method to interact with the DLT. just to recap, every single node interact with the DLT to store the public key within a DID document. So a DID method is a software implementation that provides at the lower layer the read and write primitive, and on top 4 different APIs that are referred to be CRUD. The first one is create. What does it mean, create? Once I have generated my key pairs, I have to create my DID, the decentralized identifier. No? So I have to define the address on the ledger at which I want to store my DID document. So create a DID means generate the key pairs, generate the document, store, put the public key inside the document and store the document on the ledger. Resolve. This is very important. We use and we see the role of resolve in the authentication procedure. Resolve a DID means I receive a DID, a URI, from a peer in the infrastructure, and I want to resolve it. That means I want to retrieve the DID document and, in particular, the public key of the counterpart from the ledger. Essentially, the DID are pointers that the node exchange to create and give information where to retrieve the public key. Of course, update the DID or the DID document. Why these 2 different options? Essentially because every single node can decide to create its own DID and at a certain point change, update this DID for any reason, because I lose access to my private key, or because simply I want to go through key rotation. So I want to change in some way the keys at a certain point. I can change and use a totally new DID, or I can only update the DID document on the ledger. Of course, the last API is delete. This is impossible because a DLT is an immutable means of storage. So delete become revoke. Revoke a DID, because I cannot delete a data from a DLT, but I can revoke my DID. What does it mean, revoke? Revoke means create and store on the ledger a cryptographic proof that this specific DID has been revoked by me, or in case of a digital infrastructure, by that specific node. So update a DID can be create a new one and revoke the previous one, or I maintain my DID and I update my DID document. Now, how 2 different peers are going to use the layer 1, the DLT, the DID documents, and their key pair to start the authentication between them. This in this slide is just a slightly different representation of the first 2 layers that we have seen at the beginning when I presented the overall stack. Essentially, peer A generate its own key pair. The private one stored securely on the node, and the public one, he used the DID method to create its own DID document and store the public key inside a DLT. The same for peer B. Essentially, start the authentication means have one of the possible cryptographic algorithms to let each one knows and be proved that the counterpart peer knows the private key which bounded to the public key stored on the ledger. So the peer exchange the ID such that peer A can retrieve the public key of peer B using the DID method, in particular the resolve. Resolve a DID means retrieve a DID document stored at that specific DID, that specific pointer on the ledger. The same for B. At that point, each one can prove the possession of the private key and have this very first cryptographic authentication between the peer in the infrastructure. This is just a note. In particular, in some critical infrastructure, a very good idea is to generate the public, the private and public key, so the key pair at the core of the identity using hardware secure element in such a way this component of the identity is bounded to the hardware of the object, but it's just a possible implementation that, in my opinion, is better than having simple software keys generation of the keys, but it's not required. Now, layer 2, the two different nodes start the authentication. This is not enough. We arrive to layer 3 to finalize the authentication and then proceed with authorization. Here, there is a different representation of the triangle of trust that we have already presented at the beginning. There are, in this case, an issuer, an holder, and a verifier. This node and this node are the same represented here, no? But one proves part of his identity to the other, and then if you want mutual authentication, the other way around, the node that acts as a verifier then acts as an holder of the verifiable credential and verify each other. What they exchange? Exchange what is called verifiable credential. Verifiable credential are really a digital representation of any possible credential that you think are useful to represent, to complement the identity of your node in the infrastructure. The idea is that in some cases, a key pair, a DID and the DID document is not enough. I want to provide a much more interesting or how to say, a more complex representation of the identity of that specific node. And so a verifiable credential is made by some credential metadata. We will see then this metadata. A claim, essentially the part of the credential that represent and describe the identity of the nodes, and a proof. The proof is a digital signature made by the issuer. The holder typically does not send this verifiable credential directly to a verifier, but use a different data model that is called verifiable presentation. A verifiable presentation simply wrap a verifiable credential. So again, there are some metadata and a proof. What is the difference between these two proofs? The first one, the proof or a digital signature in the verifiable credential is made by the issuer. This proof in the verifiable presentation that wrap a verifiable credential is made by the holder. Again, as for the ID document, a verifiable credential is a digital document in JSON format in which we see again a context, a unique identifier of the credential in this particular case, number 2, then the type of verifiable credential you can define in your own implementation of this digital identity solution, the kind of verifiable credential that your issuer is going to issue, in this case, a very simple basic credential, the URL of the issuers, issuance date, when this credential has been issued, the expiration date, in this case 1 year, but every single developer of the issuer can define these metadata, and then the claim, the much more important part of this credential, that is called credential subject. Inside the credential subject, there is the DID of the peer, and then every single developer is free to design and issue credential with the credential subject that they prefer. In this case, to make the example very, very simple, the property node of name this IoT network. So in this kind of verifiable credential as a very simple claim that say that the holder of this credential, so the node receiving this credential, is a node that belong to this particular IoT network. But again, you are free to implement any kind of complex as you want credential subject field to describe in much more details the identity of that node. And then again, a proof, the proof made by the issuer with the signature at the end. And this is the verifiable credential. The verifiable presentation simply wrap a verifiable credential where the proof, in particular the signature, is made by the holder of this verifiable credential. So these are the two very simple data model of such a kind of digital credential. To conclude, this model can be adopted really in any kind of connected system, fully decentralized solution in which the developer of the identity solution can describe and complement the very basic component of the digital identity of a node. I mean, the key pairs, the DID and the DID document with verifiable credential that can be used to finalize authentication, then go through authorization. What I mean? I mean that authorization is essentially the decision taken based on the credential subject. Maybe I can say, I can make it more complex and say, this is a network node, maybe complement this information with another information that give access to write operation and maybe not to read operation. And so I can simply configure the access policy based on the credential I'm going, the issuer essentially use when issue a credential. So is the field or the field in the credential subject that are the input for the authorization procedure. And since this kind of approach is, first of all, standardized, can be fully configurable because I'm the owner of the overall infrastructure, so I'm the owner of one of the issuer, and I can issue credential with the credential subject I prefer. I can define the policy for authorization, and I can use, if I use a very lightweight implementation of such a model. We, for example, at Links Foundation have developed the entire stack in C language. You can use it also in IoT objects with the constrained resources. And this is it. And give the floor back to Silvio.
Thank you, Andrea. We are a little ahead of schedule, so anybody having questions, please feel free to open your microphone and directly ask. What we have seen, I would say, is that cybersecurity is much more than a firewall, and that cybersecurity needs to be basically conceived when designing a system. It's not just that easy to retrofit an existing system. So Andrea, one thing that I would like to ask you, if you can comment on how maybe is it possible to make secure an object that has not been designed as intrinsically cyber secure?
Yeah, essentially you can, for sure, if you are able, for example, to install and run such a kind of identity because the object, the system let you do it, you can, as a first step toward a more secure, let me say, the development of a more secure solution, install such a kind of identity and use it in to make or to build a trustable interaction between the nodes of your infrastructure. Of course, you must be able to do that. You must be able to access the node. You must be able to install such a kind of framework, and you have to, if you can, if you are allowed to do, rewrite part of the simple application running on the nodes to make use of such a framework, because essentially this framework complements the part of the, or is built on top of the TCP IP stack used to communicate with another node. So you can add such a kind of identity if you are allowed to work directly on the node. In some cases, some specific cases, in particular, in such in some kind of infrastructure with a lot of legacy device, we propose a solution, sort of add-on boxes installed in front of these devices that deal with such a kind of authentication and authorization, and just and only after authentication through these add-on boxes, the legacy, I mean, node that cannot be modified, and only after authentication the legacy node enter in interaction. So as a sort of really add-on boxes that make much more secure the communication among them.
Thanks, Andrea. Any questions from the audience? Okay, if there's no questions from the audience, I can think we can move forward to the conclusion. First of all, you will receive, you see in the chat right now, the link to the YouTube channel of the STARS project, in which the recording of this tutorial will be uploaded. You will anyway receive in your email the slides that have been presented today, together with the link to the channel. Let me now just share a few more slides to show you the next events that will be organized in the very short term by the STARS project. So first of all, if you would like, I suggest you to subscribe to the B2B matchmaking platform of the STARS project, in order to have the possibility to participate to several hacking match events that will be organized by the project itself. These kind of events are meant to put in contact companies that have a problem related to the railway sector that can be solved by technology providers. So we are organizing a sort of hackathon-like events in which specific problems are addressed by technology providers, and that are being followed up by matchmaking events in order to allow traditional enterprises to find the perfect solution providers with the tech-savvy SMEs. Then we have a few events organized for the month of May. At the beginning of May, like on the 4th of May, same time as today, we will have a tutorial on the use of 5G technologies for mobility purposes. Then at the 10th of May, there will be a webinar organized together with the ERCI platform that is related to cybersecurity for railway passengers in freight. And in this case, we are not discussing about cybersecurity of objects, but we are focusing on the other kind of cybersecurity I mentioned at the beginning of this tutorial, that is the cybersecurity of the information technology aspects, so basically of data. And then by the 11th of May, there will be a tutorial on sustainable development. So please feel free to get in touch with any of us for information about these forthcoming events. Or here in this last slide, you can find the emails of Florence and Andrea, in case you want clarification about the technology analysis and about the specific content of this webinar. So thanks again, everybody, for attending this meeting, and we'll keep you posted about this forthcoming events.
Sylvie, may I interrupt you? There is one question in the chat. Which is the estimated extra cost in percent for having a cybersecure system?
Andrea, did you read the question?
Yes. Very difficult to say because really depend on the, let me say, the starting point. So the situation of the system, and depend on the level of cybersecurity that you want to reach, and so the number of solutions that you have to customize and deploy on the infrastructure. So let me say it's quite impossible to answer with a number such a question, but what I can say is that you can analyze and maybe estimate this cost doing such a kind of analysis. So you analyze the starting infrastructure, so what you have now on the field, what is the level of security that you want to reach, and so you can select among different the solutions which are the most appropriate, and then estimate the cost for sure customization, because there is no one solution fit all, and deployment.
Thank you, Andrea. If there's no other question, I think we can conclude the tutorial. Thanks again, everybody. And I hope to welcome you on the 5G tutorial on the 4th of May. Thanks, everybody.
Thank you, Silvio. Have a nice evening.
Thank you. Bye-bye.
Thank you. Bye.